If you've consumed a lot of media, you should be familiar with the trope in which when something grand falls, nature suddenly thrives. Sometimes it doesn't feel rational, especially when literally the exact moment it falls, you see vegetation suddenly blooming. But it does set the mood, so it is what it is, right? However, it could actually happen in real life, especially if we're talking about under the sea. Are you familiar with the term whale fall? When a whale dies, the corpse will sink to the bottom, and when it sinks to the deep below, into the bathyal or perhaps the abyssal zone, it will provide tons of food. Literally, tons of food. Because the creatures deep below are used to the lack of food, a single whale fall could provide nutrition for years, decades even. Hence, many animals gather at a whale fall. And not only that, some animals bloom from the carcass, just like when you see those scenes where flowers bloom from the fallen giants or something. Well, kinda. Not exactly, but this is our topic of this video, Osedax. So, let me bring up the question. What exactly is Osedax? Osedax are worms. To be precise, they are annelids, the segmented worms. Within the annelids, they are classified within the Sedentaria clade. The name is pretty easy to remember because they are the sedentary annelids. But if you aren't familiar with the term sedentary, it basically is the opposite of active. Sedentaria are annelids that stay on their specific spot, usually on the bottom of the sea. Within Sedentaria, they are usually classified within the Sabellida order, which includes many famous marine sedentary annelids, such as fanworms, feather duster worms, Christmas tree worm, which I talked about quite a while ago, etc. However, Osedax are not closely related to the examples that I gave. Osedax are classified in the Ciboglinidae family, which includes some obscure worms, but also some of the most famous worms, like the tube worms, including the giant tube worms that are famous for living around hydrothermal vents. Though various phylogenetic analyses showed that Osedax is their own clade within this family, so not exactly a close relative to the tube worms either. I might have accidentally shown it by now, but yes, Osedax is actually the genus name. They have various common names. If I have to call them with a common English name, then I personally prefer the bone-eating worms. But apparently, some also call them the snot worm. And actually, various online articles call them the zombie worm. But if you are familiar with the concept of zombie, then you would notice that these worms don't exactly deserve that name. Hence, I prefer calling them Osedax because it's actually a nice name. Osedax basically means bone devourer, which you could argue that it's technically also not exactly fitting for them, but we'll talk about that later. Osedax is actually a relatively new genus. They were described in 2004. And okay, alright, I know that some of you might raise your eyebrow and think, what do you mean relatively new? That was 22 years ago. Well, first of all, I'm pretty sure some of you are not even 22 years old yet. And second of all, most animal genera were actually described decades or even centuries ago. So yeah, a genus described in 2004 feels quite recent. But anyway, Osedax is actually quite diverse. Worms listed 34 valid species. Many of them were found in California continental margin. But that's simply because many whale fall studies were done there. Osedax could also be found from various spots throughout the ocean, so they might be cosmopolitan, and there might be many more species that we simply haven't discovered yet. But now, let's talk about their morphology. But before that, females of some Osedax are decently sized. They can be around 1 to 10 centimeters long, which might not seem that long, but it's still quite something. However, the males are dwarves. They are microscopic. Most of the ones that we know are at least 20,000 times smaller than the females. The males of Osedax frankpresi are even 108,000 times smaller than the females, which is definitely something. However, the males of Osedax priapus are relatively big compared to the males of other species, with an average volume of 0.267 cubic millimeter, and the female is also relatively small, averaging 0.86 cubic millimeters in volume. So the males are only 3.2 times smaller than the females, which is still quite something if I do say so myself. The females look like a worm. By that I mean, they look vermiform. You know, long and cylindrical. While males kinda look like flatworms. That's the simplest parallel I could give at least. Females can form a gelatinous tube, encasing their body. Unless you pull them out of their tube, of course. The front part is typically reddish, and the tip of it, aka the pulp, have pinnules, which give them a feather-like appearance. They don't have a mouth, and actually, they don't even have a gut. Looking at the opposite end, the posterior part is covered in a sheath, which makes it look bulbous and greenish. This tissue sheath also branches into a root system, which we'll talk about in the ecology section. By the way, what I've been telling you is basically the general form that they could have. Different species could have some variations in several traits. For example, in some species, all of their pinnules are oriented dorsally. Some of them don't even have pinnules nor pulps. Some could have different pigmentation, etc. Like I said, they are quite diverse, and there might be many more species that we simply haven't discovered yet. But now, let's look at the males, which, to be fair, does not have many peculiar traits. The anterior tip is a prototroch, which is basically the mouth of a trochophore larvae of many marine animals. The posterior part has hooks. And yeah, that's basically it. Oh, I suppose I could point out that their body is relatively transparent, and you could see the sperms and spermatids inside their body. But yeah, the males are paidomorphic, pretty much resembling the larvae. Now you might be wondering, why are they built like this? And so, let's talk about their ecology. Like I hinted earlier, they are found in whale falls. They were given the name Osedax, the bone devourer, because they bore through whales' bones and live there. Sometimes you could find multiple colonies from multiple species of Osedax in a single whale fall. Though, I would like to clarify that, even though they are mostly found in whale falls, they could basically live on any kinds of bony materials. That means you could grow them on various media, like cow bones for example. They could even live on shark teeth, also human skeleton of course. Just pointing that out in case a creature designer wants to design that kind of creature. The root system as a structure anchors them to the bone, but that's not the only function of it. To put it very simply, their posterior sheath could secrete acid to dissolve the bone matrix. Mechanically though, it's not as simple as quote-unquote just secreting acid. They utilize proton pump and carbonic anhydrase to create an acidic condition, which then dissolves the bone matrix. In a way, it is quite similar to how osteoclasts work. By the way, them boring into bones is not only to anchor themselves. This is how they feed. Or I suppose the more technically correct phrase is, this is how they obtain nutrient. Because remember, they don't have a mouth and they don't even have a gut, so they need to absorb nutrient through their epithelium basically. Their pinnules on the anterior end is not just ornamental of course. The pinnules basically function as gills. I would also like to point out that they have endosymbionts in the form of various bacteria. Some of them could help in bone material digestion, while some can help protect them from various potentially harmful environmental conditions, which will most likely happen at some point because they live on a decomposing carcass after all. Hence, more and more substances will be released to the environment. This 2023 publication showed that their endosymbiont community is dynamic, changing over time to fit their environmental condition. Endosymbiotic bacteria are not the only one that live within them though. The males also live within them. Well, within their tube at least. Multiple males, even more than 50 individuals could gather around a female, living inside her tube. Observations showed that bigger females typically host more males, which imply more and more males will gather to a female as it grows. Males of most species don't eat, so they are basically there just to give their sperms to the female. Meanwhile, males of Osedax priapus, which I specifically mentioned earlier, remember the ones which males are not significantly smaller than the females, that ones do digest bones, just like the typical female Osedax. Having the males basically sticking to the females is quite convenient because it somewhat ensures fertilization. Not only that, having a paidomorphic dwarf males can also be beneficial as a species because competition between sex will be lowered, especially good in an environment where food can be scarce. And they also don't take too much space, which could be beneficial, but I'm not sure if it's relevant for them or not. Anyway, during spawning, the oviduct will extend into the crown among the pulps. They can spawn hundreds of eggs each spawning session, and for many of them, development can be quite fast. Eggs could develop and hatch into trophophore larvae in about a day. And trophophore larvae means they swim freely in the water column. That's how they could disperse and colonize a new whale fall or any other skeletal remains that sink to the bottom of the sea. When larvae found a suitable place, which is a bone of course, they will hook themselves to it, and then they will begin metamorphosing. After 2 days, the root will form and they will root themselves to the bone. After 4 days, they will form symbiosis with bacteria, and after 10 days, they basically have reached their adult form, albeit still growing. Oh, by the way, I was talking about the females of course. The males would just find a female and settle within its tube instead, and they barely change from their larva form, like I pointed out earlier. And yeah, that's Osedax. Now let me ask you a question. Which part of their biology would warrant their zombie worm nickname? I personally think none of it, but I don't know. Maybe I simply did not see the vision. Keep in mind that what we know about them are based on our observations on some specific species, and some of those are ex situ observation, not being done under the sea, their natural habitat. The point is, some species could have a significantly distinct ecology, and the ones that we observe might not even be representative of their natural way of life. Also, like I said earlier, there might be even more species that we haven't discovered yet. Good news for those who are interested in them because there's still a lot to learn. Who knows what we'll learn in the future. But for now, let's just learn what is known. And that's all for now. Oh, by the way, even their bore mark is different between species. So, to some extent, you could identify what Osedax was living in that bone, which could be handy in fossil works. Anyway, enjoy your day.